In this video, I'll be walking through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-3. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around my channel. Okay, let's get into the maths. In question 11, they tell us about two functions, f and g. For f, they've given us the function, and for g, they've only given us the inverse. But actually, for part A, we're not going to need this, so I'll go ahead and rub it out for now. In part A, they want us to concentrate on fx, and they give us an extra bit of information. They tell us that the range of fx is bigger than or equal to minus 33. That means that the number that comes out of this function will always be bigger than or equal to minus 33. I'll never get below that, which is interesting. And they want us to use that information to find the possible values of a. That's another hint there. There's more than one answer. The values of a. So what do we do here? There's two ways I see to doing this question. I'll go ahead and do both of them because they have a lot of similarities, so the second time I'll be able to do it quite quickly. Both of them though rely on you knowing a little about this function, specifically what it looks like. This is the x-axis. I don't know where the y-axis is, but I know that this function, it's a positive number here. So I know it's a U shape. And I also know the bottom point of it. I know it's minus 33. Because they tell me the range is bigger than or equal to minus 33. Even if I didn't know this was a positive, the fact that it's bigger than or equal to, I would know that it's a positive from that. So another way to think of that is this point here is minus 33. And that might help you. That's one of the versions of doing this question, going from the point here. Also, some students might be able to write down something for x right now. I'll talk about that as we go through the question, where you might get that number. In fact, it's just from reading here. It's doing something with this number, tells you what goes here, but we'll deal with that in a few moments. The first way I'm going to do this question is by completing the square. That's writing fx again. But instead of like this, I'm going to write x squared plus 4ax plus a over here. I'll leave myself a bit of room. I would love if this was a square, something that's just nice squared number. And I can do that. Completing the square method just means just make up a number that makes it work. And that's half of this number, half of this number squared. So we'd get 2a squared here. That would make this a perfect square. That's x plus 2a. Wouldn't that be nice? I've just added this number in, so I can do that once I just take it away again. There, I've not changed anything on this line. And now I can write this line, this would be minus 4a squared plus a, and this is still fx. I can just write it like this. Using this information here, this tells you a lot about the shape of a function. It's really handy for quadratics. It tells me a lot about the lowest point, which I'll talk about in a moment, which you don't necessarily need. Or this gives me the lowest point. Because have a think what this is. Something squared. The only place x is in this square here. What's the lowest number a square can be? It can never be minus. So the smallest this can ever get is 0. But I know it goes all the way down to minus 33. So if the smallest this can get is 0, this number here must be minus 33. So really the answer to the question is minus 4a squared plus a must equal minus 33. Let me go off on a slight tangent just to show you another way you could have solved this. I'm going to show you in 2 more ways, but just very quick little tangent is when this is 0, think of what x is. X must equal minus 2a. And you could go ahead and use this information to solve it as well. But I'll do this in the second part, but I'll find this a slightly different way. And let's just go ahead and solve this for the moment. This is a quadratic, we just need to clean it up a bit. Change signs, move things like that. Let's move everyone over to the right. 4a squared minus a minus 33 is equal 0. If you're not very good at solving quadratics or solving them using factorizing them, use the minus b formula. There's no problem with that. In fact, a lot of fancy calculators will solve it. Actually, probably not even that fancy anymore. You can put a quadratic into a calculator nowadays. But it does factorize quite easily. 4a times a, and it's 3 and 11, I think. We need the 3 here and the 11 here, because that will make 12 and 11, and that combines to get a 1. We need minus 1, so I would need minus 12 and a plus 11, and that gives me a minus 33. So your two answers here, this is full marks for part A, although I'll go ahead and do it again, is A is equal minus 11 over 4, or A is equal to 3. That's full marks. What was the other way to do it? I don't need much more room. The other way you could have done this from the very start is, if you knew it looked like this, we're talking about a stationary point. Stationary point, differentiation. Let's do it here. The derivative of f is just 2x plus 4a. That's the derivative, and that equals 0 at this stationary point. Rearrange this, you would get x is equal minus 2a, which we also got from here if you wanted. Once you have this point here, remember what this is. This is the y part and the x part. X and y. We could, let me put this up here. It'd be minus 33 is equal this squared. So minus 2a squared would be 4a squared. And minus 2a multiplied by 4a would be minus 8a squared, and a plus a, which I'm not sure, hopefully you can just about see. Rearrange all this, we'd get 4a squared minus a minus 33 equals 0, which is the same as this function, same as this, get the same answers as that. So at least two different ways, I guess 3 different ways. If you start with completing the square, you could have gone 2 different ways in that. If you got this point, you could have gone to here. And differentiation as well. Okay, that's part A. Let me clear off a lot of this and we'll go on to part B. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. For part B, we are going to need this g function, or the inverse of g that they've given us, because what they ask us involves g. They ask us to, or I guess they tell us that f g 0 of 0 is equal to 96. Find the values of a. First of all, let me rewrite this. This is shorthand. What this is saying is it's f of something. That something is g of something, and that something is g of 0. That's what this is, just quick hand for doing. To do all this, I basically, what goes into f's function? I don't know. What goes into g's function? I don't know. What goes into this g's function? 0. I do know that. That's where I should start. But to do any of that, I need to know what g is, and I don't. So before I start this question, we need to find g. We have the inverse of g. How do I find g? Well, the inverse of g is, the inverse of the inverse gets back to g. Inverse is just switching something, and you can switch back as well. You can just switch twice to get back to where you started. So what this question really boils down to is getting the inverse of this. The inverse of this gets you back to g. To get the inverse of a function, how I do it, there's slightly different ways. I just write out this function as y is equal 2x minus 4. And then I switch the x and y. Some people switch the x and y later. That's fine. Doesn't really make much of a difference. Cube root of 2y minus 4. I now just rearrange this so y is on its own. And whatever that is, that will be inverse of this function I started with. So just start to try and rearrange it so y is on its own. First thing you'll need to do is get rid of this cube root. That's easy enough to do. Take the cube of both sides. The cube of this side is x cubed, and this just destroys that side. 2y minus 4. Rearrange this, we get x cubed plus 4 is equal to y. Let's switch the sides though. We'll have y is equal x cubed plus 4. The 2 though, where'd that go? I'm going to divide over here. That's the inverse of this function. But we know the inverse of this function is, let me write it up here. The inverse of this function is back to g. So the inverse of this is g, the inverse of this is also this here. So that's x cubed plus 4 over 2. That's the first thing you would have needed to do to solve this question. It's not too difficult from this point on. This is all equal to 96. To do this, we just need to know what g0 is. G of 0. And that's easy now. I know what g is. I just put 0 in. 0 cubed, let me write it all out. 0 plus 4 over 2. That's 4 over 2. That's 2. So let me write this again. It's f of g of 2. I'm replacing g of 0 with just 2. So now I need to know what g of 2 is. Just put it in. 2 cubed is 8. Plus 4 over 2. Obviously, you don't have to write all this out. 12 over 2 is 6. Let's write it again. Instead of f of g of 2, it's just f of 6 is equal 96. So we move on to that function. We just get f of 6 is 6 squared, 36, plus 4 sixes is 24 times a. Plus another a is equal to 96. My voice is gone there. Okay, quick cough and a sip of water. I'm fine. 26a plus another a is 25a, and that's equal to 96 minus 36, which is 60. A is equal to 60 over 25. Let's see, 5 goes into both of them. 12 times and 5 times. That's your answer. A is equal to 12 over 5. That was a fairly generous question to end the exam on. What they really asked you there was, what's the inverse? Just find the inverse. And do you remember how functions work? Nested functions like that works. So if you did remember how this works, and you were able to get the inverse, there's 6 marks for you there. I think I've probably only worth about 3 marks, but still you got 6 marks. There's your answer. That's it for question 11. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.